Hello and welcome to Apidays Paris. My name is Stéve Sfartz and I will give you a presentation speaking about managing OpenAPI document at scale, giving you the best practices we've been using, which tools have we been using at Cisco. So welcome. Myself, Steve, I lead Cisco's API Experience Program. What we do is we define internal standards regarding the design, the life cycle, and the documentation so that the developer experience is great for our customers and partners. And this covers the whole portfolio of Cisco's. There's a lot of value with OpenAPI. I gave a talk last year called the 12 facets. You will also see it as 18 facets lately on the internet, where I go into the details of everything you can do with an OpenAPI document. Today, I want to look into the scalability, and we will dive into breaking changes. How can you manage them? And looking at the static analysis and live traffic observation for OpenAPI documents. So I hope we have a good time together. You love this session, and after the session, you can still reach out to me on the internet and at the Cisco booth at the conference. So let's start with vertical scalability. Um, OpenAPI documents, what means large for a document? So if we take pet store, it's a pretty small document, I would say. 13 path, 19 operations, 800 lines of YAML. What you do, you still want to automate a bit your workflow by creating annotations and or code comments in your OpenAPI, or comments in your code, so that you can automatically generate these OpenAPI documents. So that's still manageable to create these OpenAPI documents manually when you have a few dozens of paths and operations, but not really when you start scaling the work. So what means large? At Cisco, it means, I would say, we often refer to large as the Meraki dashboard API, which is our just like model in terms of large. 400 paths, 600 operations, 70,000 lines of YAML. And then we've got the extra large APIs that go to hundreds of thousands of lines and thousands of operations. So when you deal with those numbers, of course, you cannot edit them manually anymore. You cannot even review changes manually. Generating change logs, you want to automate, and the rendering of the documentation can be a struggle just due to memory consumption. So vertical scalability, what does it mean? It means you will need to be shuffling, splitting these documents, looking at automation generators that can scale to this amount of lines. So do some testing, certainly contribute back to some of these open source projects I'm showing here. When your documents start getting very large, what we would recommend across Cisco is to split the documents into domains, certainly business domain. So you can imagine something about, for us, it would be networking, policies, provisioning, observability. So you can certainly pick this API and organize it in subdomains. So that would be the job of splitting. It also works the opposite way when your teams are organized and in very domain logic way. Then you would certainly want to come up with resolving references. We call it resolving with a bundling strategy. And then comes the rendering, so the sorting of these OpenAPI documents, and also filtering out some of the details that you've been added as extensions so that you can scale. You can deploy internally, for example. You can add extra tags through the OpenAPI extensibility. So at the end of the day, this is what's going to happen. We've covered vertical scalability. Let's look at horizontal. So What about the number of APIs you have? So that would really depend. At Cisco, we have more like the thousands of APIs, hundreds of engineering groups, each operating across different domains and with very independent organizations, from networking to security. And you see the different domains we have on this screenshot here. That can be a struggle. That brings its own challenges in order to scale your guidance, and that's what we're going to look at now. How can you organize this horizontal scalability? So, what are the challenges? Every day flourishes a new API program, so that's great. But also, you need to educate, coach, and look at the compliance of this API. Second thing would be the consistency. And sorry for that, I'm going to fix it live. It's about API design, of course. Consistency in your design, in the documentation, in the way you support, you provide technical support. And also the lifecycle and backward compatibility. I'm going to dig more into these details. So the more APIs, the more you have to scale your program, of course. Solution to that, an inventory. You need to start organizing with an inventory day one, automation, and then organizing compliance. That is the only way you're going to survive. I would say a large API program, or the diversity of API programs across a large organization. So let's look at the OpenAPI documents first. So this is the basic flow you will find where your product manager or product owner starts with originally crafting what would be the design of this API. Then engineering groups, they add extra parameters, schemas, define the errors. So they provide something we call complete. If you've not seen the conference I gave earlier, which is called Why API Contracts Matter, please look at it. I'm provided more details into API contracts and this particular part. So comes another revision of your OpenAPI documents, and multiple of them. And over time, you're ready to publish, and you start doing more closer work with your technical writers. And finally, you publish the docs. So this is a pretty naive explanation, process-driven. In reality, you will need to do some coaching around engineering teams and tech writers, and the product manager will be very important there, so that you can edit so that you can have a single source of truth for these OpenAPI documents, versions, and revisions. So certainly different Git repos, and then forking, cloning, pushing back a pull request, how to merge a change. That needs to be organized, and that needs to be organized at scale. It's a natural skill for engineers. For tech writers, yeah, you will certainly want to create a specific training, which is what we did at Cisco. Then, because you have got many documents and they can be also very large, you want to do some as much as automation as possible. So the magic tool, pretty much a de facto leader in the industry, is called Spectral from Stoplight. So the linter does a great job at helping you create rules and running these rules against your documents. Of course, the larger the documents, the longer the rules can take. And if you've got already very large documents, you will need to look at complementary tools because Stoplight and Spectral would be a bit too slow to process some of these documents. You suppose you've been setting up a linter now, you have those rules backed into your toolchain. Now you want to automatically check that whenever an engineer commits some code, you will have along the CI/CD pipeline a connection with your static analysis and analyzers you have. and you're providing for your organization, you certainly want also to buy a few of the marvelous offerings you will see here at Apidays Paris, a pretty large partner booth with many tool sets that can help you score the security, the quality of your documents. And then when you go live, you will also want to capture, reconciliate the release that has been deployed with the latest revision that has been scored, and check if there's any discrepancies between the live traffic of the version you're seeing and the actual contract that was defined. Again, this was explained in more details in the Why API Contracts Matter talk. Now what I want to look at is what is it we want to do along the CI/CD pipelines? What are the challenges? So with a large organization, you will have various CI/CD pipelines organized different ways. Some are on-prem, some are deployed in the cloud, many of them are hybrid. There's also a bit of sensitivity to the information you're looking at now, these OpenAPI documents. Getting access to these documents is providing a lot of details about where the product is going. So you want to protect this information. And for that means access to the OpenAPI documents must be seriously considered. Third, you will want to customize the rules you have defined. Suppose you're using Spectral, there's very low chances every group is using the same design conventions, race conventions. In fact, there is no chance. What you want to do is certainly to organize a common set of rules and then to help your teams identify when they are not meeting the default rules of your organization, but you will also need to customize for historical reasons. Maybe a company got bought, an acquisition, or maybe someone started earlier. So it would be a bit naive to go with a unique set of race conventions. It's still important as the North Star for your company to define what should new APIs look like and what should engineering groups adopt and embrace over time. But definitely you will want to have multiple REST conventions and have your CI/CD pipelines be in capacity to load the REST convention that really correspond to every engineering group. Also, technical leads across groups will have different practices. What means failing a pull request? So imagine an OpenAPI document doesn't meet the latest recommendations and conventions internally. Should it be rejected? Should it fail below a score? What is an error? What is a warning? So that's important. You've got flexibility there. And lastly, we want to look at enforcing a few of these requirements. And for that, at Cisco, we ended up creating our own internal tool based on multiple open source libraries we found. And this is an example of what the tool gives you. Us at Cisco, it's like you've got the domain. So in this group called API Experience, you've got one API here, which is your demo example. You've got multiple revisions, and for every revision, you will start scoring. So these are three analyzers. One looks at inclusive language and terms you want to avoid across your documentation. The documentation itself, how descriptive is it, how consistent is it, and the contract, which really connects with the skeleton, the technical contract, the schemas for every input request and every response you can get from this API. This is what we call the technical contract. And you want to define analyzers. And for these three, you can certainly have company-wide compliance, which means it will be exactly the same. This is what you want to drive as compliance for the company. And then you want to have other analyzers that are fully customizable for every engineering group or organization in your team. So considering this, I want to give an example. Let's look at backward compatibility. It's been an initiative I've been looking at for the last 2 years at Cisco. So we started with looking more into automating the backward compatibility moving forward for Cisco APIs. What does it mean? Certainly, a lot of work can be done manually. So, like generating a change log, identifying breaking changes, escalating, documenting, versioning, and deprecating. But if you have an OpenAPI document, for example, for REST API or other formats such as GraphQL, this is what we call the definition of the API. So, if you have one, a lot of the work you're seeing below can be automated, and that's what we're pushing for. We're pushing towards internally. So let's consider you have established principles. Principles are great, but at the end of the day, guidance, versioning is what we built initially at Cisco, and we keep expanding it. But if you want to really drive compliance, you will need solid requirements that can be easily read by engineering. And once they are put out, such as the ones I was showing here, then you want to automate most of the work. So looking into the tool sets that will automatically evaluate for us, it's a completeness of the contract. Is it fully described? If it's fully described, that means you've reached a target of 100% for completeness of your contract, and there is nothing missing. And the end of the day, if you've got something complete, you can generate a full changelog, what we call complete, accurate. Whatever has been described, you will be able to compare whatever revisions of your APIs. And from there, you can automatically start detecting breaking changes. So a non-backward compatible change that you don't want to release, otherwise it will become a breaking change for your community. So all the automation and compliance, it goes into several steps. First, defining the guidance, getting approval across your company about what these different recommendations should be. The larger your company and the more decentralized it is, the more we have at Cisco organized with an API experience group that has representatives from every organization and engineering group in order to get consensus, the requirements, and then doing the automation to help you along. Conclusion today, what does it mean to manage OpenAPI documents at scale? First thing is looking at the tools that can help you generate and render reference documentation. It may work for 100 lines of YAML, but I would strongly suggest you start looking at what happens with hundreds of thousands, maybe 1 million lines of YAML. I'm pretty sure we have APIs at Cisco coming that will very soon get to the 1 million lines of code. Of course, you don't need to support necessarily millions of lines of YAML. There's very good chances you can split this document into multiple sub-documents, starting from one larger one and splitting it into multiple, or starting from very fine-grained OpenAPI documents. We call them fragments at Cisco, and then generating larger OpenAPI documents per domain. So, but I think that hundreds of thousands of lines is reasonable to support, and to make sure all your system can support at least 100,000 lines of YAML. Second thing, you want to be in capacity to score. You want to score automatically your OpenAPI documents, reject automatically whatever change if it doesn't meet your every engineering group criteria. The design, sooner than later, when you can look at these errors for breaking changes, it's exactly the same. You don't want to identify a non-backward compatible change just before release. And lastly, you also want the last tool that looks at the live behavior So I talked again. Please refer to the why API contracts matter. The live behavior and comparing traffic from the exact OpenAPI documents you have is also critical. At Cisco, we've got a tool for that called Panoptica, part of Cisco Cloud Application Security. Please come to the booth, and we'd love to discuss with you about your own challenges and also do a demo of what Panoptica can offer for you. And I want to leave you with these 3 questions. Take a paper and start writing down what is your OpenAPI toolset today to offer, render, and manage compliance. How do you really store these OpenAPI documents, and are you in capacity to identify every revision and how they come up? How do they match the API lifecycle? Semantic versioning can really help there. And how many OpenAPI analyzers do you need? It's pretty sure that it's not 1, it's not 5. There's certainly more like 10 minimum, because depending on the perspective and what you want to track or enforce, you need to look at the analysis of these OpenAPI documents from different perspectives, different angles, and it needs to be also customized. So something to consider when you organize your toolset for scalability. And thank you so much for your time today. Again, looking forward to meet at the booth and also on the internet. You can see us at developer.cisco.com. And for everything API security solutions at Cisco, please go to panoptica.app. See you soon. Bye-bye.